Hello everyone, welcome back to another video session on the subject EC308 Embedded Systems, and we are in the sixth session for Module 6. Well, in the previous session we were discussing about the MUCOS RTOS, and we started our discussion about various service functions, and it was the system service function that we discussed in our previous session, and we stopped right there, right? We also had a detailed discussion about the features of MUCOS, why this MUCOS was commonly used in a wide range of applications. So in this session we shall see other service functions used in MUCOS, the task service section functions, the memory related service functions, even the semaphore related service functions. So it will be a quick look into this, because we have already seen that these functions are pretty easy to understand because of their easy naming conventions. So we shall see what is the purpose of each of these functions and how these functions are defined. So to begin with, the task service functions. So these service functions are basically meant to create task, suspend task, resume, delay, or delay the resumes of task. So these are everything related to the operation and the states of task: creating task, suspending them, resuming them, delaying them, and so on. And these functions are responsible for declaring the variable assignments and the prototype assignments for each task functions, and these are done using the preprocessor command functions for creating, suspending, resuming and delaying the task. So let's see each function one by one. The OS task create. This function must be called because, as you can guess from the name, it is task create. So only if this particular function is called, the operating systems can schedule and context switch for processing the task. So in this kind, the task stack pointer, stack size and the priorities all are defined in the preprocessor commands. The other function, the unsigned byte OK task suspend, as the name indicates, see, OS task suspend. These are called for blocking or suspending a particular task, and if there is a suspension, there is resume. The OS task resume function. This is called for resuming the blocked or suspended task. So we have created the task, suspended them and resumed them using various functions. Similarly, we have functions for generating time delay. So when your task need to be delayed for certain system clock periods, you will have to use the function OS time delay. This is quite understandable from the function name itself, right? So they will generate a particular delay for this particular task. The other function that is related to the task service function is the OS time delay, hour, minute, second and short millisecond. So hour, we have the hour, minute, second and the short millisecond. So all these, so when there is a need to delay and block a task by specifying the hours, minutes, seconds and milliseconds, you will use this delay. In fact, these both delay functions are same, except that while using this delay function, you can get an idea about the hour, minute, second and millisecond of the delay. So when a detailed specification of the delay is needed, you can use this function. That's it. Now the the final operating system task service function is the OS time delay resume. So when a task of particular priority is to be resumed before a particular delay is applied. So in such cases, we will have to use this function. So resume time delay. The delayed task need to be resumed before the specified time delay. Right, that's it. So you have to resume the task before this time delay. That is the indication of this function. And the final function is the OS task del. Definitely it's task deletion. So delete the task of priority. And this task delete should be used only in very exception cases, such as when your memory runs short. So in such cases, you can call this function, this particular function. So if you see, this task service function was all about creating the task, suspending them, resuming them, and applying delays. So this was the normal delay in terms of hour, minute, seconds and millisecond, and here you are resuming the task within this time delay, and here you are deleting your task. So right from studying this function names itself, you can also find the explanation for these functions. These are beautifully named, right? So another service function is related to your memory allocation. So we have already, when we were discussing the features, we have seen that the MUCOS, they have a fixed memory block allocation form. So this makes your system much faster compared to the dynamic allocation of memory. And the functions that this MUCOS perform while doing functions related to memory allocation are creating memory blocks, getting memory block, querying a memory block, and putting a memory block into partition. So let's see what are the functions which we use for each condition. So for creating, definitely the function that we use is OS memory create. So here we are using the memory address, memory type, and the number of blocks, the block size, the memory error. So this is the operating function. This can partition the memory from an address with specific blocks, and there is proper creation and initialization of the memory partition into blocks. So this memory create helps you create blocks of memory. So you will need the memory address, the number of blocks you need, the size of each blocks, etc. So our first task in memory allocation is creating memory, and that's done by this function create. The second task is getting a memory block. So you have right now created, now you want to get a memory block, you want to retrieve a memory block. So your function is OS memory get. So you are getting the memory from blocks of memory, right? And the third function is querying a memory block. This function we are using to query a set of memory blocks and return the error code and pointers for the memory partitions, and the function is OS memory query. So see, from this itself we are able to make this function name OS mem query, right? So this function basically returns a error code, and this will be a unsigned byte. So the value will be 1, the error code value will be 1 when your querying succeeds, else it will be 0, right? And the last kind of memory function that you use is putting a memory block into partition. So what are the things that you did so far? You have created the memory, you got a memory section, that means you are retrieving a memory block, you are querying a memory block, and finally you are putting. You have retrieved something, we have to put something back, right? So the function for this is OS memory put. So unsigned byte OS memory put. So what does this unsigned byte and things indicate? Right. Now, so this function, they return this memory block which is pointed by this memory block pointers, right. So they are returning values into this. Okay, fine. So these are the functions which are related to memory allocation service functions. So far we have seen the system level service functions, the task service functions and the memory allocation related functions. Finally, we shall see the semaphore related functions. So already we are familiar with what are semaphores. So these are used for synchronization, resource sharing and synchronization. And we have already discussed during the feature section that the semaphore that is created by your MUCOS, this can be used as event signaling flags, and this can also be used as mutex functions, right. So while you are creating the semaphore related functions, you must do the following. You will create a semaphore for the IPC for inter-process communication. You will wait for an IPC for semaphore release so that your resource is available. Then you will check for the availability of an IPC after semaphore release, send an IPC after semaphore release and retrieve the error information. So in each case, you have a similar function which performs the task, and this task of creating the semaphore, the function name is OS event OS sem create, semaphore create. So this is used for creating the operating systems event for an IPC control block with the particular semaphore value, and they will return a point which will point to your ECB control block, and a semaphore is created and initialized with the value sem val. So that's it, you are creating a semaphore. Once that is done, you will wait for an IPC for semaphore release. So for that you use the function void OS sem pend. So you are making a task wait until the semaphore has been released. So you are making that the particular task wait for the semaphore release. So this can be done by using this particular function. Then once that is done, you will have to check the availability of an IPC after semaphore release, which means you are ready to accept whether if there is a free semaphore, you are ready to accept, and your function will be short OS sem accept, and they check for a semaphore value at our ACB, and if it is greater than 0, they are ready to accept that semaphore, right. And the next task is you are sending an IPC after semaphore release. So your function is OS semaphore post, and it is for you're letting another waiting task which need not wait afterwards, and your IPC is set for the release of your semaphore. So that's what this function is used for. And your final function is for collecting the error information of a semaphore, and you use the function OS sem query, and this puts the value of the semaphore at your pointer sem data, semaphore data. So these are the functions which are related to semaphores. So we have seen the actually in very brief, we have just seen what are the functions which are used for various MUCOS purposes. So it was for system level, we had certain functions. For task, we had a set of functions, similarly for memory and for semaphore. So once you get the notes, please go through the notes also, so that you will get a better clear idea regarding these topics. So by that we are winding up the video sessions for module 6 with this. So please go through all the previous sessions and understand the concepts clearly. Thank you and have a great time.